Sorry. So a pleasant day, STEM learners. So this is now your pre-calculus with Sir Peter. Are you ready? For week number 2, we will be discussing about the parabola. And for this video lesson, we will talk about the definition of a parabola. So at the end of this video lesson, you should be able to define a parabola and its parts and illustrate parabolas in standard position. Let us begin. In our week 1 discussion, we defined the parabola as the cutting of the plane is parallel to one and only one generator. Then, the curve becomes a parabola that is pertaining to the intersection of the double right circular cone and the plane. Do you still remember this one? Now, a two-dimensional parabola can be defined when it is plotted on the Cartesian plane. So, by definition, in analytic geometry, a parabola is a set of all coplanar points that are equidistant from a fixed line and a fixed point, but not on the fixed line. Observe that based from the characteristic of a given conic, the parabola is considered a two-dimensional conic because it possesses three characteristics. The first one is the fixed point. Okay, we also have the fixed line. And that fixed point is not part of the fixed line. So in this illustration, the focus is what we call the fixed point. It's the focus of the parabola, while the fixed line is called the directrix. Notice that the fixed point is not part of the fixed line. Okay? Next. So the fixed line is called the directrix. So observe the line here, this one. This line is called the directrix. And notice that it is not part of the blue curve. The blue curve represents our conic, but the directrix is part of its exterior. And the fixed point is called the focus. Notice that the focus of the parabola is the one that the parabola opens with. So if it opens upward, then the focus is above the vertex of the parabola. Now, we also have a line segment, which is perpendicular to the directrix. And what is that line segment? Look at this violet line. The violet line is called the axis of symmetry. So why is it called the axis of symmetry? So the line perpendicular to it is said to be symmetric with respect to that line. So as you observe, the parabola is which opens upward here is symmetric here on this part, and from the vertex it is also symmetric. So meaning every point on the parabola has also a corresponding point on the other side of the parabola. So that is where the line of symmetry, or what we call the axis of symmetry, is observed. The chord, so again, it is a line segment that passes through the focus and perpendicular to the axis of symmetry is called the latus rectum. Notice this line, this one. So this is an imaginary line segment drawn, no, which is perpendicular to the axis of symmetry. So we call this line as the latus rectum. The latus rectum is a special distance, which is what we know as 4c. Again, the latus rectum is a distance, okay? And in algebra, it is represented by the distance 4c. So what is c distance? The distance from the vertex of the parabola going to the focus is what we know as the c distance. Consequently, the distance from the vertex going to the directrix is also a c distance. So therefore, the distance from focus to the directrix is 2c. Okay, so that is 2 units. So if c is 5, meaning there are 5 units from the vertex going to the focus, therefore, there will also be 5 units from the vertex going to the directrix. Okay, so they are equidistant. Now, what about the latus rectum? Observe the latus rectum. It is 4 times the c distance. So, if this is c unit, then we have c, 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 and c here because the latus rectum represents a distance which is 4c. So if the c distance is 6, therefore the length of the latus rectum will be 24. Did you get it? So that is our latus rectum. The point on the parabola midway between the latus rectum and the directrix is what we know as the vertex. So this is the midpoint between the focus and the directrix. Okay? The midpoint between the fixed point and the fixed line. This is the line. Question. The vertex is the point where the curve changes the direction. So as you observe, this is not like the circle because the circle has a center. But in a parabola, the vertex, okay, becomes our turning point. Okay. Now, a parabola is said to be in standard position if its vertex is at the origin and its principal axis is one of the coordinate axes. Observe the given figure. The red line indicates the graph of the parabola which opens upward. Okay. The illustration below describes a parabola which opens downward. And observe that the coordinate axes are their axis of symmetry or what we know as the principal axis. For example, for a parabola which opens upward, the axis of symmetry is the y-axis itself. For a parabola which opens downward, the same. The axis of symmetry is also the y-axis. So it is the coordinate axes which are the principal axis. So let's talk about the different parts of the parabola in standard position. So if the parabola opens upward, the vertex is the lowest point. Do you agree? Okay, so this is the lowest point. And if the parabola opens downward, the vertex is the highest point. So it's the total opposite. Upward means we have a minimum point, and a downward parabola which opens downward would mean a maximum point of the graph. In terms of the directrix, notice that the directrix has equations line y is equal to negative c or line is equal to c, depending on the position of the directrix with respect to the vertex. For example, if the parabola opens upward, notice the vertex. The vertex, okay, and in relation to the directrix. So what is the relationship? So as you could observe, so line y is equal to negative c is located below the vertex. Okay, so nandun siya sa baba. So if the parabola opens upward, then the directrix is a line represented by y is equal to negative c because it is below the vertex. When the parabola opens downward, it's the opposite of the equation of the directrix because the equation of the directrix is represented by y is equal to positive c, in which its location is above the vertex. Okay, so I repeat, when it's below the vertex, it means the parabola opens upward, referring to the directrix. The equation is y is equal to negative c. If the parabola opens downward, then the line, which is the directrix, is represented by y is equal to c because it is located above the vertex. Question. Next, we have the focus. The focus is again c unit above or below the vertex. So the same with the distances. The vertex of the directrix, it also has the same distance from focus going to the vertex. So if the parabola opens upward, the focus is located at 0c. So whatever is the c distance. And if the parabola opens downward, the focus is at 0, negative c. The reason is the focus is located below the vertex. Okay, it is below the vertex. Next. For the axis of symmetry, both the parabola which opens upward or downward have x is equal to 0 as our axis of symmetry. Or x is equal to 0, the line x is equal to 0 is also the y-axis per se. So remember that in the axis of symmetry, it is the line that divides the parabola into two parts, which makes it mirror images of the other. So for every point on the parabola, there is an exact mirror point on the other side. Always remember that. And that is because of the axis of symmetry. A vertical parabola is a parabola which opens upward or a parabola which opens downward. So all of these are parabolas in standard position because they have vertex at 0, 0, and we refer to them as vertical parabolas because their axis of symmetry are vertical lines. Did you get it? So these are the examples of vertical parabolas in standard position. Now, what if the parabola opens to the right or it opens to the left? Notice the directrix will change the equation of the line. So the equation of the line of a parabola which opens to the right is x is equal to negative c. Notice this blue line, this one. This is the directrix. Okay, so the directrix is located to the left of the vertex. That's why it's negative c. So when we say left, it's negative. For a parabola which opens to the left, the directrix is located to the right of the vertex at 0, 0. So therefore, the line is represented by x is equal to positive c. And this is x is equal to negative c. Whatever is the c distance. Did you get it? Okay. Next. For the focus, notice that since we have 4 units here, so we should also have 4 units there, and here also 4 units, because the directrix is equidistant to the vertex, and the vertex going to the focus of the parabola, which either opens to the left or the right. Now, if the focus is at C0, it means it's to the right of the vertex. So meaning, focus is at C0. And for a parabola which opens to the left, focus will be at negative C0 because the focus is located to the left of the vertex, which is the origin. So the axis of symmetry is this time the x-axis. So look at the x-axis, it's located here and also on this figure. So the x-axis is the horizontal line represented by the equation y is equal to 0. And that is also the x-axis. So since the axis of symmetry are horizontal lines, okay, with respect to a parabola which opens to the right or to the left, then we refer to them to these figures as horizontal parabolas in standard position, since it also has vertex with coordinates 0, 0. Okay, so again, we refer to these figures as horizontal parabolas. So as a summary, standard equation of a parabola which opens to the right or left is this one. Notice that y is squared and c is linear. In the formula, you can see the value of the latus rectum. Okay? When it is a parabola which opens upward or downward, then the quadratic part is the x part, while the linear part is y. So, nag-interchange lang sila. So, the standard equation is y squared is equal to 4cx, and the focus is at C0. However, we also have another standard equation, which is y is equal to negative 4cx. So if the formula is negative, then this parabola opens to the left, while this parabola opens to the right. For the focus, it is located at negative C0. Okay? And for this one, we also have x squared is equal to negative 4cy, meaning this is a parabola which opens downward. So for a upward, it's 0z, and for a parabola which opens downward, it's at f 0, negative c. Notice that whatever is the sign of the coordinate of the focus at C is also giving you an idea about the direction. So if it is negative, it's either to the left or downward. If it's positive, it's either it's right, it opens to the right, or it opens upward. So for the latus rectum, here are the formulas. The axis of symmetry for a horizontal parabolas, it's y is equal to 0, and k is equal to 0, and for this one we have h is equal to 0, which is also our x and the y values respectively. For the directrix, we have to, when the parabola opens upward, it's x equal to negative c, but when the parabola opens downward, it's x is equal to c. So it's the opposite direction. Okay. Sorry, I mean to the, this is to the right, and this is to the left. When the equation of the directrix is upward, it's y is equal to negative c. And for downward, we have y equal to c. So that is the summary. Always remember that parabolas are everywhere. Okay, so you could see it in Pampanga High School, no, on amusement park, on church, no, on some monuments, and of course our favorite place, no, McDonald's, JBL. So these are the references used in this presentation. So did you learn something? So for our next video lesson, we will also have a second part of parabolas. So we will be talking about the standard equation of a parabola, vertex at 0, 0. But this also can be named as parabolas in standard position.